Hello, everyone. So, in this lesson, I want to introduce uh, what lesson 5 is all about. And after this, I would make another one uh, so that you could watch these and then uh, practice or follow with your workbooks. Okay? All right. Now, in lesson 5, we are going to be looking at quadratic functions. Quadratic functions. And we are going to be talking about the characteristics of quadratic functions. The characteristics of quadratic functions. Now, to start with, what is a quadratic function? And how do I know that a function is quadratic? So, just give me a minute. Let me fix something here. Okay, there we go. So, here in this function, which is a quadratic, we have the form f of x equals ax squared plus bx plus c. But you have to make sure that a does not equal 0. Why is it very important that a is not equal to 0? The reason is that if a equals 0, the x squared part goes to 0, right? Because 0 times x squared is 0. So what do you have? You have a linear function. And what is a linear function again? Mx plus b, right? And here we're going to have bx plus c, right? So bx plus c. So you would see that the b would be our slope, and then c will be our y-intercept, or the y value of that intercept, okay? Now, this is the general form of a quadratic, but we'll talk about the standard form, if not today, later, okay? So, this is the general form. It is a degree 2 polynomial, and you could see that right from here, right? You could see that from there, okay? It is a degree 2 polynomial. It has 3 distinct terms, each with its own coefficient. So let's look at the first term. The first term is that, the second, and then the third. So we have an x squared term with a coefficient of a. We have an x term with a coefficient b. And then we have a constant, right? Which is a c. It is a constant. Remember that if any term is missing, then the coefficient is 0. So if I have ax squared plus c, what this means is that our bx equals 0. What this means is that our b is 0, x, which gives us 0. So that's what we are saying, okay? That's what we're saying. All right. Now, what about the graph? Now, the graph of this function is always going to be a parabola. Now, a parabola has a U shape like that, or it could either be that. It's either going to open up or open down. Here it's opening up, there it's opening down, right? So please do not forget that. And we usually say this is concave up, concave down, all right? Or opening up or opening down. Now, A, if you look at the general form up here, A determines which direction the parabola opens. A determines which direction the parabola opens. So if A is greater than 0, then it opens up. If A is greater than 0, then it opens up. Then we have a concave up. If A is less than 0, then it opens down. Concave down. Okay? Now, just as we noticed from linear functions, the vertical intercept or the y-intercept is going to be our C here. Why? Because we know that for y-intercept or vertical intercept, x equals 0. So if I put in f of 0, so I put in 0 for x, I'm going to have a times 0 squared plus b times 0 plus c. So this goes to 0, that goes to 0. What do I have? C. So when x is 0, y is c. So that is always going to be your y-intercept. So please do not forget that, okay? All right. Now, what about the domain? The domain, that is the set of possible x values or input values. The domain is always going to be negative infinity to positive infinity. Negative infinity to positive infinity. Okay? All right. Now, let's quickly look at some of the problems. So, I have, oops, let's go to problem 1 first. So look at problem 1. That is a worked example, but I still want to look at it real quick. Okay. Now we have this quadratic function, f of x equals x squared plus 4x minus 2. It says complete the table and generate a graph of the function. Okay. Now identify the coefficients a, b, and c. Now from this general form, we're going to compare that to the function we have. So from here, what I see and what you should see is that my a is 1x squared, but of course you don't write 1x squared, but we just want to say that there is a 1 there. My b is 4, and then my c is going to be negative 2. Now remember, c, you have plus c, right? And you have negative 2. So the way you see this, because the general form says it's plus, so you put your plus here, right? Because positive times negative gives a negative 2. So it is negative 2. C is not 2. It is negative 2. Now, which direction does the parabola open? Look at the a value. Is a greater than 0? Yes. So it's going to open up because a is positive or is greater than 0. Now, what is the y-intercept? The y-intercept is negative 2. C equals negative 2. So as an ordered pair, we have 0 when x is 0, y is negative 2. If you don't remember that, then set x equals 0, put it in the function, and then find your c. But of course, you're going to get negative 2. All right. Now, let's go to problem 2. Now, in problem 2, we have another function, x squared minus 2x plus 3. We are supposed to complete the table. So a equals 1, b equals negative 2, c equals 3. Where am I getting these values from? Ax squared plus bx plus c. X squared minus 2x plus 3. So we have 1 for A. And then here, same idea, right? You've got plus B, so you have plus here, like that. Okay? All right. So negative 2 for B, and then C is plus, so you do 3 or positive 3. Okay? Now, which direction does the parabola open? Again, it's going to open up. Because A is greater than 0, or A equals 1 is greater than 0. What is the vertical intercept? Again, the vertical intercept, remember C equals 3, so we have 0, 3. Now I have to draw the graph. So how do I draw this graph? So remember that we've got our y-intercept, which is 0, 3, so that is going to be somewhere here, 0, 3, right? And here it is really a sketch, so I don't expect you to do like to draw an accurate graph. Okay, an accurate graph. That's not what I expect. Again, you could also go to the calculator and then look at how the calculator would look like. I mean, the graph would look like, right? So you could always do that as well. So if you go to the calculator, so I'm going to do that now. I'm going to share that. Yep. So second mode, y equals. So I'm going to erase what I have here. And what was the function? X squared minus 2x plus 3. Yeah, I think I got it. So I have x squared minus 2x plus 3. Now I'll go check my window real quick. I've got a standard window, so that's fine. You see how it looks like? Now the point here, what is it? Is our y-intercept. Y-intercept is our y-intercept. Okay. All right. So you sketch this graph. So getting the graph shouldn't be so much of a hassle if you know how to put in your the function for y1. Okay. All right. So let's go back to the workbook. All right. So I've drawn my graph from the picture that I saw on the calculator. All right. Now with problem 3, you've got the same idea. So you've got a function 2x squared minus 5. Now you would see that the b term or the x term is missing, right? So what is my a? Ax squared, so a is 2. What is my b? It's going to be 0. What is my c? It's going to be negative 5. Why? Because we are looking at ax squared plus bx plus c. And I have 2x squared. Now I don't have anything here, then I have a negative 5. So the negative 5 tells me that this should rather give me a plus negative 5. Now in the box here, I know that this is going to be 0x. So b is 0, 0x. Now which direction will the parabola open? Remember, and why? A equals 2, so it opens up. It opens up. What is the vertical intercept? it's -5. That's it. And then again, you draw your graph. Now, what is the y-intercept? 0, -5. So that is going to be somewhere here. 0, -5. And then remember, this is going to open up. Again, if you are not sure of it, you go to your calculator and then you put it in your calculator, and that should give you what you are looking for. It should give you what you're looking for. All right. So let me go to the calculator again real quick and then show you what is going on. So y equals, and then I'm going to erase what I have here, 2x squared minus 5. Oh yeah. So I have that. So you'd see that this part, oops, here is our what? The y-intercept. The y-intercept, which is 0, -5. I would label the y-intercept, okay? All right. So far, so good. So far, so good. Now, let's talk about some other characteristics or some other very important aspects of the quadratic function. Given the quadratic function f of x equals ax squared plus bx plus c, the vertex. Now, what is the vertex? The vertex is the lowest or highest point on the graph or of the parabola. So if I have this and then I do that, my vertex is going to be at this point here. So that is the lowest point on the graph. Now, if I have this too, my vertex is going to be at this point, the highest point on the graph. But you would understand or notice that now if I tell you to find the point, the exact point of this vertex, I want the numbers. What is x? What is y for this point? Because it's a point on the graph, so it's got x and y. Now, it's going to be difficult. Why? Because you might not get the exact. You might think that, oh, I'll just do that, but it's going to be difficult sometimes to find it, find the exact. So we've created a formula to help us find this vertex so that we get the exact values for x and y, or the exact point. So we have to find the x, we have to find the y, right? The x and y to get the point we are looking for. Now, to find the input value or the x value, there is a formula. And what is that formula? To find the x, that is it. X equals -b over 2a. Okay? Now, as we've always done, if you have your x value, whatever you get for x, you put it in whatever function you have, you put it in for x. Yep. And then solve for y. Now remember that our minus b, our b and then a, how do we get those? We get those from the function, right? The function given to us. Then we use that to find our vertex. So the vertex is always going to be this formula. For x, you have, this is x, this is y. So for x, you have -b over 2a. For y, you have put x into the function f of negative b over 2a. Now, what is the axis of symmetry? For axis of symmetry, this is a vertical line that intersects the vertex. So it's intersects, it goes through the vertex, that point, it goes through it and then divides the graph in half, or divides the parabola in half. So if I have this parabola and this is my vertex, the axis of symmetry is going to be a line that would go through that, like that. So this line is going to be my axis of symmetry. Now, this axis of symmetry has an equation. It is a vertical line. It has an equation. Now, because it is a vertical line, it's always going to have x equals some number. I'm not going to use a because we are using a for so let's say x equals d. So it's always going to be x equals something because it is a vertical line. Vertical lines always have an equation, x equals a constant, right? So it's always going to have that. Now the d here, the d, x equals d, is always going to be the x value of the vertex. So if you are told to find the equation of the axis of symmetry, you are always going to have the x value. Why? Because it passes through the vertex xy, right? And if we are saying that the equation of axis of symmetry should be x equals a number, then it should be the x value here. It should be the x value here. So if I find my vertex x and y, finding my equation of axis of symmetry, it's so easy, right? Because you don't do much. You're not going to do much. Why? Because it's just the x value of the vertex, and that's it. All right. Now let's quickly look at problem 4. Now in problem 4, we have the quadratic function x squared plus 4x minus 2. Now this is a worked example, so I'm going to go through it. So if you look at what we have here, you would see that our coefficients a, b, and c, a is 1, b is 4, c is -2. Okay? Now it says identify the axis of symmetry equation. Identify the axis of symmetry equation. How do we identify that? Again, we have to find the vertex, and then with the x value of the vertex, that gives us the equation of axis of symmetry. So let's try to do that now. Okay, I want to erase everything on here. Why is it not going away? I don't know. I have to do this and come back. Oops. Okay, there we go. So with this, let's find the vertex. So my vertex, is going to have x and y. Now my x is going to be -b over 2a, right? Now a is 1, b is 4, c is -2. So x equals -b, -4, right? b is 4 over 2a. What is a? 1. So we have 2 times 1. So I have -4 over 2. And what does that give me? negative 2. So x is negative 2. So x equals negative 2 is going to be the equation of axis of symmetry. Remember, it's an equation. So you do x equals negative 2. X equals negative 2. Now, negative 2 is the x value of the vertex. So we have our x value. So if this is my vertex, I have negative 2. Now I have to find my y. How do I find my y? I'm going to put negative 2 into the function, right? Negative 2 for x. So let's do that. And if I do that, I'm going to switch and do that on the whiteboard, okay? I'll come back to this. So my function is x squared plus 4x minus 2. So that's what I have for my function. So x equals negative 2. So f of negative 2 equals negative 2 squared plus 4 times negative 2 minus 2. Now, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8 minus 2. So 4 minus 8 is negative 4. Negative 4 minus 2 is negative 6. So this is my y value. So when x equals negative 2, y equals negative 6. This is my vertex. Okay, now if you look at this function, you would see that it opens up. Why? Because my a is positive 1. It opens up. So we are going to get a graph like that. So this point here, the lowest point here is going to be the vertex, negative 2, negative 6. That is our vertex. And then the axis of symmetry will go through that point like that. And what is the axis of symmetry? Is x equals negative 2. X equals negative 2. All right. Now it says, oops, we should sketch the graph, right? We should sketch the graph. So remember that you have your vertex, which is the lowest point. So you know where the lowest point is at, which is negative 2, negative 6. Now, do we know our y-intercept? Yes, we could find our y-intercept. And what is the y-intercept? Go back to the function. The function is x squared plus 4x minus 2. So our y-intercept is 0, negative 2. So I have my y-intercept somewhere here. And then I have my vertex here. Okay? And I could draw the graph. I know it's opening up, so you sketch. And then you draw your line, your axis of symmetry line, axis of symmetry, draw it there. Now, you could always go to the the calculator, and then get your graph there. All right? Okay. Now, in problem 5, we have a media example. So there is a video on the website, but I'm going to go through it, maybe not all of them, because I expect you to watch the video on the website, myopenmath.com. All right. So we have f of x equals x squared minus 2x plus 3. Find the coefficients. A equals 1, b equals negative 2, c equals 3. Where am I getting these values from? Ax squared plus bx plus c equals f of x. Now, if you compare that to the function we have x squared minus 2x plus 3. So a is 1, b is negative 2, c is positive 3. Now, it says find the coordinates of the vertex. So we know that to find the vertex, we have x, y. X equals negative b over 2a. And then my y is f of whatever I get for x, I put it in. So let's start with the x. So x equals negative b over 2a. Now, what is b? Negative 2. So I have negative 2 over 2a. What is a? 2 times 1, which is 2. Now, from the top, negative b, negative 2. Negative times negative is positive. So I have 2 over 2, which equals 1. So x is 1. X is 1. So my equation of axis of symmetry is x equals 1. X is 1. Now, how do I get my y? I'm going to put in 1 for x in the function. So let's do that. I don't know if I have more space. I think I have to go to the whiteboard. So I'm going to use that. So the equation was f of x equals x squared minus 2x plus 3. I think that was it. So if x equals 1, I have f of 1 equals 1 squared minus 2 times 1 plus 3. 1 minus 2 plus 3. 1 minus 2 is negative 1 plus 3 is 2. So when x is 1, y is 2. This is my vertex. Okay? This is my vertex. And then graph the function. It says plot and label the vertex and axis of symmetry. So you plot and label the vertex and axis of symmetry. So the vertex is, was it 1 and 2? Yeah, 1, 2. So 1, 2 is going to be somewhere. Oops. Yeah, it is too small that it's so difficult to get the accurate point. And then the y-intercept is going to be 0, 3. So that should be somewhere here. Oops, no. Somewhere there. 0, 3. But it says you should label, right? So you go that way. Again, you could always go to the calculator and then use the calculator. Oops, no, this is terrible. Oh no. Oops. Yeah, I mean, yeah, you could get the graph, okay? So, yeah, draw the graph in your workbook and then label, and then draw the line, the axis of symmetry. Draw the line. All right. Now, in problem 6, again, we have a function f of x equals 2x squared minus 5. For this one, a equals 2. We already did the coefficients, right? I think in problem 3 or something like that. B equals 0. C equals negative 5. Now, what is the equation of axis of symmetry? I have to find the coordinates of the vertex. How do I do that? I have x equals negative b over 2a. And then y is f of whatever you get for negative b over 2a. You put it in. So let's do that. What is x going to be? Now, our b is 0, so from the top, you get 0. Now, because you are getting 0 on the top, you know x is going to be 0. And then 2 times a is 2 times 2. So you have x equals 0. So you put x equals 0 in this function. F of x equals 2x squared minus 5. When x equals 0, you're going to have 2 0 squared minus 5. Now, 2 times 0 squared is 0, so you have minus 5. So 0 minus 5. That is our vertex. So what is our equation of axis of symmetry, or the axis of symmetry equation? X equals 0. and then you draw the graph. We already drew some of these graphs, right? We sketched some of them in the past in problems 1, 2, and 3. All right. Now, the next thing that I want us to talk about is going to be, where is it? Oops. Domain and range. Domain and range. Domain and range. Determine the domain and range of the quadratic function f of x equals x squared plus 4x minus 2. Now, for the domain, if you remember when we started, we said the domain is all real numbers. That is negative infinity to positive infinity. Now I have an inequality notation and an interval notation. Any of them is fine, or you just write all real numbers. Again, why is it all real numbers? Look at this graph. The x keeps on going, right? It's going to keep going like that. Kind of like it's going to heaven, right? It's going up, 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 up. So it's going up, 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 up. So it's going to what? Negative infinity, positive infinity. But what can we say about the range? The range is the set of possible y values. Now look at the graph. Look at the graph. Oops. So you would notice that the range is from here and then it keeps going, right? Because as this goes up, the y also goes up. But the y has a starting point, kind of. It has a starting point. That is at where the vertex is, right? And then it's going up. It's going up. So this tells me that the range starts from, what is the y value for the vertex? Negative 6. So from negative 6 to what? Positive infinity, because this part is positive, right? This part is positive. So it's going to positive whatever, positive infinity. So this is going to give me negative 6 y, or f of x. Remember, infinity is not a number, so you do less than infinity. But here we are saying that the negative 6 is part of the values of y, and that is why we have a closed. Okay, we have a less than or equal. So f of x is greater than or equal to negative 6, but it's less than infinity. That's what we're saying. All right. So I hope that helps for range and domain. Now let's look at the next one. We have negative 2x squared minus 6. Now we're supposed to draw the graph, and then we are supposed to find the domain and the range. Now we do know that the domain is going to be all real numbers. Now what about the range? Now, from what we just did, to find the range, you have to know the vertex. You have to know the vertex. So let's find the vertex. Now remember, to find the vertex, you have x is negative b over 2a. And then whatever you get, you put it in your function. Okay? So, let's keep going. Now, with this function, what is a? A is negative 2. What is b? We don't have a b, so b is 0. And what is c? I mean, we don't need a c, but let's just write it down, negative 6. Right? Remember, ax squared plus bx plus c. All right. So, my x value of the vertex is going to be negative b. What is b? 0. Negative 0, which is 0. 2a, 2 times, what is a? Negative 2. By this point, you know you're going to get a 0. So x is 0. Now I'm going to put x equals 0 into the function. So you have f of x equals negative 2x squared minus 6, f of 0 equals negative 2 times 0 squared minus 6. This goes to 0, so you have negative 6. So for my vertex, I'm going to have 0, negative 6. Wow, 0, negative 6. Now, look at this function. Is it going to open up or down, and why? Is it going to open up or down, and why? Remember, to know if a graph opens up or down, it depends on the a value. Now, here we do see that the a is negative 2. It's less than 0. So the graph will open down. It's going to open down. It's going to open down. Now, what is the y-intercept? The y-intercept is 0, negative 6. So look at the y-intercept and look at the vertex. They are the same. Sometimes the y-intercept and the vertex are the same. Now, I would quickly, to draw the graph, I would quickly go to the calculator and then see what I'm going to come up with. So y equals, I'm going to erase this, and then I'm going to do negative 2x squared minus 6. And then I'm going to go graph. Look at what I have. Let me do this again, because I think I have a problem here. So I'm going to clear everything, and then I'm going to do negative 2x squared minus 6. Check my window and go to graph. Yes, now I have it. Oh yeah. Now I knew the first one was wrong because it has to open down. It has to open down. So that is what I have. Now I could increase my y, right? I could increase my negative y values and then get a bigger graph. So let me do that quickly. So my negative y, I'm going to do negative 20. I just want to get it bigger. Oh yeah, look at it. You see that? So now it's a little bigger. All right, so I'm going to sketch this. But really, even from here, I'm trying to find the range, right? That's what the question says. I already have my domain, my range. So you know that your range would go from here to what? Negative infinity. Oops, negative infinity. Now, at this point, we know that our vertex was 0, negative 6. So for y values, it's going from negative 6 till negative infinity. So you have negative infinity, right? Because you always start from the lowest, or the lower number on your left. So negative infinity on your left. So f of x is greater than negative infinity, but it's less than or equal to negative 6. Remember, negative 6 is bigger than negative infinity, right? So when you write this down, make sure you check, okay? Try to see if you can read what you have for that, okay? Or you have that, negative infinity, and then you have negative 6, like that. Okay? All right. So I'm going to end here, and hopefully this helps you. You could start the homework with this, and we are going to continue from finding the horizontal intercepts. Thank you so much. Bye. And please, before you go, send questions to me if you have any questions. Thank you. Bye.